Hi everyone, and welcome back to another episode of Dr. Kyle Explains, your YouTube channel where we go through GCSE science content quickly and easily. Today we're going to be going through the three states of matter. Now, this is a topic that pupils generally find relatively easy. However, there are a few key concepts that you need to be aware of, and including in this video some higher tier level stuff that pupils really need to know in order to get those grade 9s. So, please give the video a thumbs up, subscribe to the channel, tell everyone about it, grab a pen and paper, and let's go ahead and jump in. Okay, so some key content first of all. So the three states of matter are solid, liquid, and gas. And just to remind you, a solid has a little s, liquid has an L, and gas has a G for the state symbols. Now, just to remind you, there is another state symbol of AQ, which stands for aqueous, which means dissolved in water, but obviously that's not one of the three states of matter. Just to remind you, it's one of the state symbols. Okay, so melting and freezing take place at the melting point, and boiling and condensing can take place at the boiling point. Now, this is sometimes a section that pupils find quite difficult to understand, and just to try and highlight it quickly, it essentially means that water, for example, at 0 degrees, so hopefully we know water at 0 degrees will turn into ice. Now, specifically at 0 degrees, it also means that ice is also turning back to water. And so these two processes are happening at exactly the same temperature. So it's the melting point is either the point where it melts or where it freezes. The same thing happens with water at 100 degrees. It's either going to boil or it's going to condense. Okay, so in a solid, particles are vibrating. In a liquid, particles are able to move around more. And in a gas, particles can freely move in any direction. So here I've got three diagrams to show you. So I've got a solid, a liquid, and my gas. And this is known as a simple model. We often draw these out to represent the solid, liquids, and gases. Now, hopefully we can see in the solid, well, obviously the particles represented as these black dots or the black spheres are all arranged in columns and rows. They're neatly tightly packed together. And hopefully we might know already that they're actually vibrating around a fixed point. And so there is a little bit of movement here. All of these particles are vibrating. Now, this is the lowest energy state. Now, if we were to add a bit more energy into this and go over to a liquid, we would melt it. And then now, in this state, the particles are able to move around more freely. However, the order is just kind of disordered. So there's no order to these particles now. They're able to move around, but we're still not in the highest energy level state. So if we now move more energy into the system, we would then evaporate our particles, or evaporation. And now we enter the gas phase, which has the most thermal energy. And these particles are now free to move around in any direction they please, fill the container, and can move around anywhere. Now, if we were to take some of that energy away, we would now condense and we would move back into a liquid. And so liquid would fill the containers, but they would still be able to move around freely within the particles. But please note that the particles are often, they're still touching. They're not able to just have these large gaps like in a gas. Less energy, we're going to freeze. And again, we'd go back to a system with the least amount of energy. Particles come really close together, start vibrating again, and become tightly packed together. Okay, so the three states of matter can be represented in these simple models that we've just shown here. In the simple model, the particles are represented as the small spheres, as we've just said. Now, the amount of energy needed to change from a solid to a liquid or a liquid to a gas depends on the strength of the forces between the particles. And so, if we want to go from a solid over here to a liquid, we obviously need to supply energy to the system to give those particles more energy. But that amount of energy depends on the forces between these molecules. And so that's why it's different between, kind of going from some ice to water or trying to melt some metal, for example. That requires a lot more energy. So the type of particles depends on the structure and the bonding of the substance. So remember, ionic substances generally have quite high melting points. And then the stronger the forces, the higher the melting and the boiling points. So covalent bonds, for example, generally have quite weak forces of attraction between the molecules, hence why not much energy is needed to move between the states. Okay, so some limitations then of these models. So as we stated, In the model, there are no forces shown. So we were talking about these forces, that they're quite weak in between these molecules sometimes, if we can go from a solid to a liquid, or they can be very strong if it's something like an ionic compound. But in these models, there are no forces shown, and that's definitely a limitation because we can't picture these in this model. All particles are represented as spheres, as we know from the plum pudding model. That's not true. Atoms are mainly empty space. And again, the spheres are all solid, showing that's not how we represent atoms normally. And so these are some of the limitations of using these models when talking about the different particles. Okay, so I thought I'd ask a question now to get people thinking and to get some more understanding on how we move between the solid, liquids and gases. So explain how a solid can turn into a gas. You must describe the structure of each state in your answer. So let's plan this really quickly together and see what we can come up with. So the first thing we're looking at is solid, and we're going to a gas. And so I'm thinking straight away, if I'm going there to there, I need to talk about melt, and I need to talk about evaporating. Okay, really quickly, just scribbling that through. So also, I'm now thinking about how I'm going to go from melting to evaporating, and so I'm going to need to be talking about energy, because I need energy to get those particles to move around more. Now, you must describe the structure of each state, so that means I need to talk about solid, liquid, and gas. And then it talks about describing the structure in each of them. So we need to talk about how they are actually packed together, how they're moving, that kind of thing. So let's start with solid. So in a solid, the particles are tightly packed and are vibrating around a fixed point. Okay, so the state has the least amount of thermal energy. So when energy is added, probably as heat, energy is added, the particles, or those solid spheres, particles will move more. Important that we're saying more because we're showing that we understand that the particles are now moving more. There's more energy in the system. And the solid will melt. Okay, so in a liquid, so we're now showing that we understand that melting turns into a liquid. In a liquid, the particles are still close together, but can now freely move. So they can move around a lot more now. There's more energy in the system, but they're still very close together. More energy is needed to then evaporate into a gas. In a gas, the particles are free to move in any direction, and now the state has the most thermal energy. Brilliant. Okay, we might just want to add about the limitations then. So the limitations of this model are particles are not solid spheres. and no forces are shown between the particles. Perfect. Well done if you got a lot of that. So essentially in this question, we're talking about the energy, we're talking about the states, we're talking about how we're moving between these three states of matter. Okay, thank you very much for watching. Please do go through my other videos on YouTube to find more quality content for GCSE Science. Please don't forget to give the video a thumbs up, subscribe to the channel, tell everyone about it, and join in next time for more Dr. Kyle Explains. Thanks very much. Bye-bye.